Okay, so this section, like I said, is on similar triangles. So we've already talked about similar triangles, right? I mean, triangles and polygons in general, we know that they're similar by looking at their angles, determining that their angles are congruent, and then looking at their sides, making sure all of their sides are proportional. So we've already talked about that in the last section. That's what we've been doing. But now this section is specifically just on triangles, not quadrilaterals, not polygons in general. What we're going to learn today only works with triangles. That's really important to remember. So when you have triangles that you're trying to determine are similar, there are some shortcuts to determine similarity, just like how there were shortcuts to determine congruency in chapter 4. So there are 3 shortcuts that we use. The first one is called angle-angle similarity, also known as AA. Sometimes we write it like this. AA with like a little similarity symbol like that. So it's called angle-angle. So this one would read, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So now, if you have triangles, all you need to know is that 2 pairs of angles are congruent. Which if 2 pairs are congruent, 3 pairs automatically are, right? Because of the third angle theorem. So if you look at this one, if I had A and D that were congruent, B, and I can't even see what that is, we'll go with E, B and E, then that would be enough to say the triangles are similar. So all you need now is 2 angles. So if you look at this picture, example 1, are the triangles similar? If so, find X and Y. Well, they gave us that we have some parallel lines here, so I could mark this congruent to this. I could do this one to this one, or I could do the vertical angles, either one. So I'm going to say that yes, the triangles are similar by angle-angle similarity. I don't even have to test the sides because all I need to know is that their angles are congruent, and that's enough. Since they're triangles, it doesn't work with like quadrilaterals or something like that. If you still have like a polygon, like a quadrilateral, something like that, you would still have to check the angles and the sides. Okay, so now that I know that they're similar, to find X and Y, I can either write proportions, or I don't know if you guys noticed the scale factor here is pretty easy one. 30 and 60 correspond. 60 is double 30. So I could pretty easily find that Y is 46 by just doubling 23. Or if you wanted to write a proportion, you could put Y over 23 equals 60 over 30. Either way, you're going to get that Y is 46 using scale factor or solving that proportion. And then X is going to be half of 38.6 because all of these are half of all of these. So you could also write a proportion, like if you didn't notice scale factor, then you could do X over 38.6. So small to big equals 30 over 60, which will end up being 19.3, which is half of 38.6. Okay. So that's the first one. The next shortcut is called side-side-side similarity. So it says if the measures of if the measures of the corresponding sides of 2 triangles are proportional, then the triangles are similar. So for this one, you only have to test the sides. So I think some of what I had in this box didn't print out, but basically you would test like this side over this side over this side, and then this one over this one to see if they're proportional. You don't have to know anything about the angles. You would only use this one if you didn't know the angles and you only knew sides, like in example 2, determine whether the triangles are similar. So since no angles are marked, sometimes kids struggle with matching up the correct corresponding sides. So just remember, like the biggest one in this one, we'll go with the biggest one in this one. And this one is like the way they're like their orientation is kind of the same. So like it's kind of easy to tell. But if this one was like flipped around and turned, you would just go like big to big, small to small. So 15 is going to go to 10. Sorry, one sec. Someone just came in. Okay. So 15 is going to go to 10. Is that equal to 12 over 8? Is that equal to 9 over 6? And so you just have to test the sides, you reduce them, see if they're equal. So 15 over 10 is going to be 3 over 2. So is 12 over 8. So is 9 over 6. So we would say that yes, triangles are similar by side, side, side similarity. And then if you were asked to write a similarity statement, it would just be triangle ABC is similar to triangle DEF. And there's your similarity statement. So this one's just the sides, and you have to check them. So like on today's assignment, the assignment I gave you today is just on determining if triangles are similar. I figured I'd give you like somewhat of an easier, quicker assignment because it's Monday. But if you're given something like this, you can't just say yes, side, side, side. Like you have to show out the work because it could be when you test it out that they're not actually similar and they're not proportional. So you can't just go like, oh, yep, sides are marked, side, side, side. Like it doesn't work that way. It could be a no. So you have to test it. So this would be your work. That's what I'd be looking for. Okay, the last shortcut that works is called side angle side similarity. And so this one says if the measures of two sides of a triangle are proportional. So this one has two pairs of proportional sides. And the included angles are congruent. So remember what an included angle is, just like side angle side with congruency, then the triangles are similar. So this one would have to look like, you'd have to put like this over this over this, and then these included angles would also have to be congruent. That's what side angle side would look like. So here's an example right here. See how we have one pair of congruent angles, and it happens to be the included angle for these two. And so now I'm going to set up ratios of the sides. So 3 over 4, does that equal 6 over 8? So 3 over 4 can't be reduced. 6 over 8 can be reduced to 3 over 4. So we would say, yes, triangles are similar by side angle side similarity. And if we needed to do a similarity statement, we could have triangle MNP is similar to triangle QRS. Okay, so those are the three shortcuts. We have angle, angle, side, 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 and side angle side. Now on the second page, there are a couple more examples. I am going to go over those because while your assignment today doesn't have any like these, your assignment tomorrow or Wednesday may. So I just wanted to go over them anyway. Oh boy, this is really hard to see. Okay, I think that's supposed to be 7.2. Just give me 1 sec. Let me just double check with the electronic version. Yeah, 7.2. Okay, so something like this. This is supposed to be 7.2. Sorry about that. So a triangle within a triangle, sometimes you may see, probably in your assignment tomorrow. Tomorrow, we're probably going to do a few proofs and then maybe a couple like algebraic type problems. So sometimes you have like a triangle within a triangle. I don't think your assignment from last week had any of this, but I could be wrong. So basically, you're given that these lines are parallel. So you could determine angle, angle. Well, first of all, like those could be congruent. You could also say this one's congruent to itself by reflexive property, or you could do like this one. So the triangles are definitely similar. And now that we know the triangles are similar, we can use proportions to find x. So see how we have this triangle here, this little one, and then we have this big one. So those are the similar triangles. And so what you're going to have to do is say like x, like the top of this small one goes to the top of the big one. What's the top of the big one? Well, we can just add these two together and say it's x plus 9. So x to x plus 9 equals 16, the bottom of the small one, to the bottom of the big one, which would be 24. And then you would cross multiply. So I just wanted to show you that sometimes you have to add the two sides together in order to get the whole thing. So this would be 24x equals 16x plus 144. So 24 minus 16 is 8. So that's going to be 8x equals 144. And 144 divided by 8 would be 18. So that's what something like that would look like. And then these next two examples, I mean, they're like very basic. This note-taking guide is from like CP. So I should have switched it up and given you some harder word problems here. These word problems are like very basic. We will do some word problems at one point. We used to have like a really cool project that we would do, but I don't really think we'll be able to do it this year because it's like a group project where you walk around the school and that's probably not allowed. But anyway, I'll still show you these two very, very basic word problems. The first one, so the word problems with similarity deal with shadows a lot. So these two both deal with shadows. And then some of them deal with mirrors, which I'll explain when I see you in school. But let's just do these couple shadow ones real quick. So if a person, here's the person, is standing, this is their shadow. So picture like the sun hitting them, hitting the person and the flagpole. It has to be at the same time of day. The angles are congruent. So we assume that they're standing at a 90-degree angle, which of course may not always be true. And then the way the sun is hitting them, it's the sun is hitting them at the same angle. So the triangles are always similar by angle. And so basically we have the height of the person, the height of the flagpole, the shadow of the person, the shadow of the flagpole. This is supposed to be 1.5 feet. So as you can see, we could write a pretty simple proportion. We could do the height of the flagpole over the height of the person equals the shadow of the flagpole over the shadow of the person. So you could go height to height, shadow to shadow. You could also do height to shadow, height to shadow. It doesn't really matter. So this is going to be 1.5x equals 42. And then you would just divide. So we would conclude that the height of the flagpole is 28 feet. So they're pretty easy. I just wanted to go over them real quick. This one is a tower, cast a shadow, 7 meters long. So here's my tower. Beautiful. 7 meters. A vertical stick. So, you know, just a random vertical stick. Cast a shadow 0.6 meters long. If the stick is 1.2 meters, I don't know, I made that so small, but whatever. How high is the tower? So see how we have the triangles. So same idea. You can go height of the tower to height of the stick equals shadow of the tower to shadow of the stick, and then cross multiply. So this is going to be 0.6x equals 8.4. And then 8.4 divided by 0.6 is 14. So that means the height of the tower is 14 meters, which actually we could have noticed. I didn't notice this till just now. 1.2 is double 0.6. So that's going to be double 7. So you could have done this with scale factor as well. Okay, so that's it. Next time we will get into some proofs, and then I'll also give you, well, maybe not, I don't know, at some point soon, I'll give you some word problems and some problems like example 4. I'm not exactly sure when, but sometime soon. So that's that. I'm going to end the recording now.